Hello everyone. I just wanted to go over a problem on one of the sample exams with you because I've received a number of questions about it. And that problem is number 3 on sample exam 2B. Number 3 says calculate the expected return, standard deviation, and coefficient of variation of a portfolio consisting of 50% investment in prime stake and 50% in pink slime. Would this investment be better or worse than the one chosen in question 2? Why or why not? So what I'm going to do is go through how to calculate the expected return, standard deviation, and coefficient of variation for the individual investments, and then we're going to create a portfolio which is 50% one and 50% in the other. I'm going to do this in Excel because I can't put my calculator on the screen here, but hopefully you'll be able to follow along with this with your calculator. So I'm going to copy this over to Excel. Just like this. Sorry, I need to do a little formatting here. So we have 3 states of the economy: a recession, a normal economy, and a boom. And the probabilities are 20% that the economy will be in recession next year, 60% that it will be normal, and then 20% that it will be in a boom state. We've got prime stake and we've got pink slime. We're going to calculate the expected return and then the standard deviation for each one. To calculate the expected return, we just multiply the probability by the return itself. So to do this, we're going to take the probability multiplied by the expected return plus the probability multiplied by the expected return in that state of the economy plus the probability multiplied by the expected return in that state of the economy. Okay. And the expected return, and actually let me cut and paste this over here. The expected return for a prime stake is 6.8%. Okay. And then for pink slime, the expected return, again, I'm going to take the probability multiplied by the expected return plus the probability multiplied by the expected return in that state of the economy plus the probability multiplied by the expected return in that state of the economy. And that gives me 3%. Okay. My standard deviations then, to calculate this, I'm going to take, and I'm going to make my life a little easier here. I'm going to say expected, I'm just naming it up here in the corner, expected prime, and this is going to be expected pink, so I'm going to take, set this equal to my return in this state of the economy minus the expected return squared multiplied by the probability. And to make things easier for me, so I don't have to calculate all that out, I'm going to drag this down. And essentially it just does it over and over again. And so the standard deviation is going to be equal to the square root, the sum of those outcomes. So you should get 12.73%. Okay. For pink slime, I'm going to do the same thing. It's equal to the expected return in that state of the economy minus the expected return for pink slime, square that, and then multiply it by the probability. Oops, need to redo that. So it's 24 minus the expected return of 3%, squared, multiplied by the probability in that state of the economy. Oops, sorry. There you go. Again, I'm going to pull this down. So it just does it for 3% and 18%. You can see the formula. So it's H6. So that's right here, the 3% minus the expected return, which, by the way, is 0. So that's why this is 2.89 to the negative 35. It's essentially 0. And then I'm going to take the square root, the sum, and that gives me a standard deviation of 13.28%. My coefficient of variation is then equal to the standard deviation divided by the expected return. So I get 1.87 in the first instance. And then in the second case I get 1.95. Right? That doesn't look right, sorry. Oh, when I drug it over it didn't change the denominator. Alright. So now we have a coefficient of variation of 1.87 and a coefficient of variation of 4.43. So now, then this is what I get a lot of questions about. What about the portfolio? For the portfolio, we just, since it's a 50% and 50% portfolio, so we're going to set this equal to 0.5. That's our weight for the for prime stake in the portfolio. I'm going to multiply that by the return in the state of the recession plus 0.5 multiplied by the return for pink slime in the recession state. So that gives me 4.5%. And then I can just drag that down again. So in this case, the second case is 0.5 up here multiplied by the return for prime stake in the normal economy plus 0.5 multiplied by 3% for pink slime in the normal economy, and we add those together, and that gives us 4 plus 1.5, or 5.5%. We do the same down here. 0.5 multiplied by 25 is 12.5%, minus 0.5 multiplied by 18, which is 9%, so that gives us 3.5%. To calculate the expected return, we do the same thing that we did before with the other investments. So what I want you to note, and really just put this in your head right now, at this point, we calculate everything the same. This is just another investment. This is prime stake, this is pink slime. We can name this baloney, okay? Or bologna, or whatever, however you want to say it. So it doesn't matter what this is called. It's a portfolio for us, but it's just another investment at this point. So we calculate the expected return by taking the probability multiplied by the return in that state of the economy plus the probability multiplied by the return in that state of the economy plus the probability multiplied by that state, the return in that state of the economy. And we get 4.9%. We calculate the standard deviation the same way. I'll call this portfolio port return, and that's going to be calculated as the return in the recession state of the economy minus the expected return squared multiplied by the probability of that return occurring. Just like I did before, I'm just going to pull this down where it does that calculation for every one of these. And then I take the square root of the sum of the three of them. which gives me 0.008 or 0.8%. And you'll see this is the answer on the answer key. Oops, looking at doing the wrong one. There we go. Okay, so if I'm going to make this look nice, I'm going to delete these three. Make everything the same size. And my coefficient of variation is equal to 0.8 divided by 4.9%, or 0.16. So if we look at this, the portfolio gives us a far better risk-return trade-off at 0.16 for the coefficient of variation when compared to the coefficient of variation for prime steak at 1.87, or for pink slime, which is certainly the worst, at 4.43. I hope this makes sense. Excel doesn't always translate that well to calculators, but you could hopefully see my calculations, what I was doing there, so you can understand how to work the problem. Again, the key thing is if you can calculate expected return and standard deviation and coefficient of variation for the individual investments, then you just use the same technique for the portfolio. The only difference is first forming that portfolio by taking the weights multiplied by the expected returns for those investments in those states of the economy. If you have any questions, please let me know. I'd received a number of questions about this problem, so I wanted to work through it for you. I'll be in my office until about 4 o'clock this afternoon, so if you want to stop by, please do, and good luck on your test.